Effects of RecOrgFert Plus on soil fertility, crop and wheat yield and quality. The LIFE RecOrgFert Plus project focuses on promoting a circular economy by transforming agricultural waste, specifically orange waste, pistazzo, and recovered sulfur, into innovative organic mineral fertilizers. This sustainable approach aims to maintain crop yields while offering an alternative to traditional chemical fertilizers. The fertilizer has been tested in pot and climatic chamber, and in open field by using winter, onion and broccoli, and spring, tomato and pepper, and the results were compared to horse manure and NPK fertilizers. Results evidenced that the growth chamber experiments, skipping the environmental perturbation avoid to that crops were impacted by climate more during summer time. During the experiments a major growth of winter crops with RecOrgFert Plus have been observed. In crop rotation with tomato or pepper, both winter crops grew better with the RecOrgFert Plus over the 2 experimental years. Broccoli and onion showed the best quality with RecOrgFert Plus. Results of climatic chamber evidenced that tomato and pepper grown in crop rotation with both broccoli and onion showed the best growth and productivity in presence of RecOrgFert Plus. Tomato and pepper with RecOrgFert Plus had the greatest antioxidants activity, and contained more carbohydrates and proteins as well as vitamin A, E, C. The experiment carried on in Calabria in open field for 2 consecutive years, evidenced a positive effects of RecOrgFert on soil. RecOrgFert increased the amount of organic carbon and decreased the pH value. In open field the productivity of broccoli and onion in crop rotation with summer crops was higher than control comparable to HM. Quality of broccoli increased in crop rotation more after tomato than pepper, and more in respect to the other fertilizers. RecOrgFert increased onion quality in crop rotation with pepper and tomato more than the other treatments. Productivity of pepper at the end of the second year of rotation was greater with RecOrgFert Plus, comparable to NPK. The same was observed for tomato. RecOrgFert in pepper increased vitamin E, proteins, and ABTS. In tomato increased also vitamins A, E and C as well as carbohydrates. The wheat experiment was conducted on 13 hectares in Lucera, Foggia, Apulia, Italy, to evaluate durum wheat productivity and quality. The soils used were classified as sandy loam, loamy sand, and sandy. Soil analysis from the first cycle indicated no pH changes across treatments. Organic matter, electrical conductivity, C/N ratio, cation exchange capacity, and total nitrogen all decreased in treated soils compared to the control. In the second cycle, however, these parameters showed increases both relative to the control and to the previous year, suggesting a time lag for fertilizer effects to become apparent in the soil. RecOrgFert demonstrated the most substantial impact, increasing soil organic matter by approximately 188% compared to the previous year, whereas NPK increased organic matter by 96% and HM by 110%, though HM had a lower absolute organic matter content than other treatments. Overall, RecOrgFert showed the most pronounced positive effects on soil quality. Wheat physiological parameters indicated that the growth was similar better with NPK and RecOrgFert in both years, respect to the other treatments. Overall, wheat quality improved with treatments in the first cycle compared to the control, although differences among treatments were not significant. In the second cycle, RecOrgFert notably enhanced seed quality, increasing flavonoids, carbohydrates, and slightly raising protein content, DPPH, and ABTS activity. Results of 2 years of experimentation in American Farm School Educational Farm Salonicco, Greece, based on durum wheat production in presence of the different fertilizers, evidenced that the data from the first year closely align with those from the second year of experimentation, showing consistent outcomes in both soil conditions and crop yield and quality. The study was conducted on a 12-hectare, non-irrigated cropland with a northeast orientation, cultivated with the durum wheat variety Giulio, 250 kg per hectare. RecOrgFert's cumulative effects point to sustained improvements in soil health over time. Although these benefits emerge more slowly than those observed with other treatments, RecOrgFert appears to stimulate soil functioning and resilience over time. The fertilizations on wheat productivity showed that RecOrgFert, even in the short term, had positive effects on wheat productivity. RecOrgFert increased seed bulk density and seed moisture content in both years. The application of RecOrgFert significantly enhanced key soil properties both in the climatic chamber and in open field trials, across various experimental locations. RecOrgFert, rich in organic and mineral components, can be transformed into sustainable fertilizers. RecOrgFert derived from agroindustrial wastes is able to increase bioactive compounds in plants. LCA analysis indicated that RecOrgFert has lower environmental impact compared to synthetic or commercial organic fertilizer. Results of this LIFE project are published in peer-reviewed scientific journals, with high impact factor. Future lab team that worked on LIFE RecOrgFert PLUS project. Partners involved in RecOrgFert PLUS LIFE project.